Welcome, viewers. Welcome to our channel, Smart Data Learners. And today our video will be very interesting. We will elaborate how to convert a relational database to a star schema. And along the way, we'll explain different methods of creating a star schema. In this today's, it's very simple. Model which we created today, but it will, we hope that it will enhance your understanding of data modeling from relational to a star schema. So enjoy the video, and thanks, and subscribe to our channel. To our channel, Smart Data Learners. Viewers, today we will be working on creating a star schema from a relational database. And along the way, we will show you what changes we will do to a relational database and create that into a star schema for further reporting. And also along the way, we will explain uh, the creation of views, and based on these views we will create a star schema. So let's start. So along the way it will clear when we will start our tutorial. So star schema overviews. Let's first go through the what is star schema. A star schema is a denormalized data model used in data warehousing, consisting of central fact tables surrounded by dimension tables. Converting a relational normalized data model to a star schema typically involves restructuring tables to create fact and dimension tables, often requiring data transformation, aggregation, or denormalization. So the role of views. Views in database are virtual tables created by query that can simplify access to data or present it in a specific format. In the context of star schema conversion, views can be used to mimic the structure of fact and dimension tables by combining or transforming data from relational data model without physically altering the underlying tables. For example, a view can join multiple normalized tables to create a denormalized dimension table or aggregate transactional data into a fact data. However, tables or aggregate transactional data into a fact. However, views are not required. The conversion can also involve physically creating ETL processes to store the star schema structure in a data warehouse. When views are used, views are often used in scenarios where the relational database remains the primary source and star schema is implemented at a logical layer for reporting or analytics, e.g. in BI tools. You want to avoid duplicating data or creating physical tables due to storage constraints or maintenance concerns. Temporary or dynamic transformations are needed without modifying the underlying data. So in today's topic, we will use the views to create a star schema. So let's go directly to our tables initial operational database. So viewers, this is our relational data model, and we have already created a video. We will provide the link when how we created this data model from a flat file. So now from flat file we have a we already created. We will provide the link to see the process of converting it to a relational database. So let's see in this data model what we have. So basically, this is a bookstore business model, and these are all tables are relating to store the information relating to business transactions in a bookstore. Okay, so let's see what they are. So this is a master transactions. This is a books transactions. This is a books. These are courses. And these are transaction types, entity, business entity, and business entity type. So, so just give you the background. Whenever there is a book transaction, we'll show you the table here. In the book transactions table, we store the transaction ID, book ID, transaction types, quantity sold, purchase price, and master transaction ID and business entity ID and the dates. So the master transaction ID, let's look into the master transaction. So this is our master transaction table. So see, in the master transaction, one master transaction could have multiple books transactions, right? And then, so let's see, for example, I'll show you this master transaction, the 15, 16, 18, 19, and these are the supplier ID, and this, it has only the main information, master information, right? So let me go back to the business books transaction. So we will see, for example, in the master transaction 15 has 3 transactions, one for this business entity. So basically, this is an operational database, and this stores the information received uh, from the data input forms. So let me give you some information on the forms also. So when the company purchased books, it used this form. And when in this form, they enter a new transaction. So basically, these are the forms where the data is entered into our operational database. So that's how this data is residing in the operational database. There are a lot of multiple tables, you know. We have for example, business entities, is either a business entity could be supplier or customer, and then they have a person name, contact person, phone, and then we linked it to the entity type, whether it's a purchase supplier or purchase customer. Then transaction type is a sale or purchase. Okay, And then we store the books information here from this table, and then we have the course table that is linked to the books table. So this is all referential integrity, and it's an operational database. So now we will convert this database to a star schema for our reporting purposes. So let's go back. Okay. So this is our star schema now. So in the star schema, you see that we have a fact underscore transactions, book ID, transaction ID, quantity sold, master transaction ID, business entity ID, and transaction date. And then we have a calendar table and dimension underscore books and dimension underscore master transaction. So you see this table, this star schema, this is a star schema. And this is our operational database. So how we converted it to a star schema? We'll now go step by step. You see in the master transaction and in the transaction books transaction, these are two different tables. But in the star schema, we have only one table, fact underscore transactions. So in the fact underscore transactions, so we created basically, these are based on the views. So first of all, we created a master underscore transaction, dimension underscore master transaction view, dimension underscore master transaction view. Let's see how it looks like. You see, in this view, from the operational database, we joined various tables, right? Database table. If we go, we have joined the master transaction with the master transaction with the transaction underscore type, right? So transaction underscore, it's one to many relationship. So one transaction type could have many master transactions. So we joined these together, and then we created business entity. One business entity could have many master transactions, right? One supplier or customer could buy, could have multiple transactions, right? One buyer or one supplier could supply many books, many different orders. So this would create a one master transaction. And then we have to identify business entity type. So one business entity type could have multiple business entities. So one business entity like a seller could have many sellers and purchaser could have many purchasers. I hope that makes sense, but let me run this view and you will see what we are talking about. So we are in the dimension underscore. So let's see in the, so in this dimension underscore master transaction, we joined, you see, we joined multiple tables to create one table. We basically denormalize, but in a virtual way. Okay? It's not a materialized view. It's we just create this in a model. It's a runtime, right? So let's into the. So we have master transaction. Then we have a transaction underscore type and transaction type underscore name, purchase, sale, like this. We have then dates and then person name, and this you see, and this person is if it's a supplier, it has a name and the phone number, right? And if it's a customer, we don't have any information because it's a sales customer, a retail customer. So these are the dates. And if we look into design view, this data comes from one, two, three, four tables, right? So we saved this table, and then if we go to the star schema, and then so if we go to the dimension underscore book, let's see how it looks like. So in the dimension underscore books, we combined two tables, courses and books, right? One course could have many books, one to many. So if we go to the datasheet view, you will see that introduction to French, author name, ISBN name, opening stock. So here we have uh, all these course name also, right? And book ID also. Course name and book ID, title. This is a book title. Then we have author name and basically we join these two tables. Course and books are combined into a one table. So we created, instead of two tables, we created one table. And master transactions, we joined these business entity type, transaction type. You see in the business we joined one, two, three, four tables, dimension underscore master transaction. One, two, three, four. One, two, three, four. So we combined these four tables into a one table. We combined these two tables into a one table, and we created a calendar table. If we go there, we have a, let's see, in the star schema. So the see now in the star schema, we now rejoin these dimension underscore books through the book ID in that, and master transactions dimension underscore master transaction through the master transaction ID to fact tables master transaction. So now it has converted these. It contains four tables. It contains two tables. So basically, it has been denormalized into a star schema based on we created the views. We can also import all this data, materialized this data, but right now we are working on a it's a small database, so views can serve our purpose. So now we it has become very simpler. You see all of these, it looks much simpler than the this this model, which has different tables. But we basically what we have done is, again I will repeat what I have said. We combine these two tables, we combine these four tables, and then we can combine the star calendar table, and this is our star schema, right? And if we run this, our star schema, so we have all this information, books, and we can use this into our reporting model. So if someone want to, for example, we want to create a further reporting in Power BI or other business intelligence tools, we can use the star schema directly and use our required data fields in our BI tools. So that's the basically our purpose of elaborating the process of relational database to a star schema. So, viewers, that's it for today, and I hope it makes sense. And if you have any questions and queries, please leave your comments in the comment section. And if you like this video, please share and join our channel Smart Data Learners. Thank you and have a great day.